All right, well, I think we're having some laptop difficulties. Does anyone have a laptop that we can use?
Yeah. And a USB key to copy the file over?
Hey, there we go. We are live already. Well, we'll hopefully, once I introduce you, I think they'll want to show up a little more. Seth Hardy is...
Ultra Laser. I was pseudonym. That's why I'm wearing the mask.
Ultra Laser is the preeminent political reporter in Newfoundland and Labrador. He currently works with CBC Television News after an initial career with CBC Radio, responsible for covering the provincial legislature. He received his Bachelor of Arts from Memorial University in Newfoundland in 1997 with a double major in English and History. He has described his role as a reporter as part gossip, part detective. Ladies and gentlemen, Ultra Laser.
Thank you. And the laptop's gone away again. Hello. Hello, laptop. It's Open Office. I need a laptop that doesn't suck. Come on. Anybody know how to work an EEPC? Oh, hold on, it just turned off. Why did it do that? Hold on 1 second. Why did... Are you serious?
There you go.
Linux is ready for the desktop.
I learned this.
All right, I'm just going to take this mask off at this point. Forget it.
What? Shardy,
My identity has already been revealed by my introduction. If my laptop will ever boot. I'm just going to work on this, so whatever you want to do. Okay. No. Come on, laptop. Oh, we're doing better. Doing better. Ignore this username. Also ignore that image. You don't know where it came from. I'm pretty sure. So this is a brand new netbook. I don't know if I like it or not. Oh, come on. Come on. All right, so I guess we will now start. So the reason for the mask is just because I wanted to say here before anything else, the views presented here are my own. I do not represent any employer, my employer, or any other employer or company. I'm going to be discussing malware here, so it might wipe your computer, steal your credit cards, and kick your dog. This is fairly unethical to distribute in a way that might infect you, so when you get the PDF copy of my slides, please be aware that the JBig2 vulnerability will be in it. So play with it at your own risk. So I'm going to start off by saying the AV industry is doomed. Has anybody here heard of Antivirus XP 2009? Yeah, it's a great product, costs $50, and then it goes away. And yeah, so don't use that. But yeah, the AV industry is doomed because all you have to do is take an executable that does malicious things to your system and call it antivirus. And not only will people run it, they will pay you money to run it. So we're all doomed. So I'm just going to cover some basic stuff. All those porn sites out there, there are problems where they're posting things that they're not supposed to be hosting, but make them a lot of money, so they host them anyways. And it generally goes, you go to a questionable site, and there's an iframe somewhere in there that points you at some JavaScript, and the JavaScript points you at something else, and then finally you get an executable file, and you're kind of screwed. Likewise, if this doesn't happen to you, well, this might happen to you. Pretty similar procedure, but you go to a porn site, there's an iframe, there's some JavaScript, then you get hit by an exploit pack, which basically looks to see what kind of browser you're running, and then hits you with every single vulnerability from the last 5 years for that browser, and because none of you patch, doom. This is how botnets happen, and this is why there is such a major problem right now out there with botnets and all of that fun stuff. So I did kind of talk about porn in my talk description. There's actually no porn in this talk, so if that's why you're here, you can just leave now. I was tempted to put the slide of Goatsy in at the end and be like, there's the porn for you suckers, but I'm actually being recorded, so I decided not to do that. So, alternate vectors. Executables are always great. This Angelina Jolie naked .scr. People will run this. People will be like, hey, tits, cool, double click, and they'll be like, what just happened? Where are the tits? Like, and you'd think people would learn, but they don't. So this is too easy. It works. If you look at recent botnets, a lot of them are using current events to try to get people to click on their links and download their malware. So if you see something that it has recent news, you're like, oh, hey, I don't like Obama. I'll click on that link to see what's going on. Or, hey, I do like him. I'll click on that link to see what's going on. It works, it's easy, and it's boring. So we're going to take a look at some other vectors malware can take and raise the question, look at the question, what kind of files out there can be safe? Well, images. Images are pretty legitimate, right? Unfortunately not, because there are many image parsers out there that have vulnerabilities in them, and because everybody on Windows is running everything as administrator, a problem in one program is a problem that compromises the system. And since everybody has the ability to look at JPEGs and at TIFFs, a problem in one of, not tits, TIFFs. TIFFs, two separate issues here. Get it? Two separate issues. Never mind. So because everybody, shut up you. Because everybody has image viewers, there are lots of ways you can find a vulnerability in an image program or library. It can be the library that Internet Explorer uses to render images. You download the image, and all of a sudden you have a problem. So how about videos? All those wonderful videos that you download off of SoulSeek or any other peer-to-peer networks, they're all crap. Like every single one of them. If you search for anything, there are programs that will generate a file name that looks like what you're looking for. And what it is, ASF files, this video container format has its own scripting language built in. Why would you need a scripting language in a video file? Well, it lets you do things like, if you're doing online streaming, it'll let you jump from one stream to another stream. It will let you easily serve up ads before going to a main content stream. But one interesting thing that it does is it lets you define a URL for a custom codec. So you get something that is usually porn, and you double click on it, and Windows Media Player says, oh, hey, you don't have the right codec installed. Here's a link to an executable that is going to give you the codec to watch this porn. And everybody goes, okay, I'll install that codec. It doesn't seem sketchy at all. What could possibly go wrong? And it's actually not a codec at all. It's just you're getting owned. So video is out. What about HTML? It's just text, right? It's just text in markup. Except the problem here isn't in the file itself. It's in what interprets and parses the file. And, well, browser exploits, like this one, right out. There's so many things that can possibly go wrong with one of these. And it's not just straight up HTML. You can get the compiled HTML stuff. You can have problems with embedded JavaScript. There was a recent vulnerability on Internet Explorer's CSS parser. So you can just have a CSS style sheet, and somebody opens that and they're owned. So this is all right out. Flash. Flash is pretty cool. Flash has an extremely high adoption rate. It runs on Windows, it runs on Linux, it runs on OS X. And the exploits for it are cross-platform, and there's Doom all around. So don't even get me started on this one. Flash is pretty bad. I will be ranting on something semi-related to Flash, but Flash is bad. So text. A text file, do I need to scan text files for viruses? Like, what could possibly go wrong in a text file? And the problem is there are things that can go wrong in text files. If it's an RTF file, there are RTF vulnerabilities where Microsoft Word, for example, will try to parse this text file and get owned. There are Unicode problems where if you've got something that thinks it's Unicode and is trying to parse Unicode characters, something can go wrong and you can get owned. So really, the moral of the story is here, nothing is safe. And I'll give you a couple examples of some really popular stuff out there that right now is trying to compromise you and everyone else you know and put you into one big botnet using files that you use every day. So yeah, anything can be malicious. Use some common sense. Peer-to-peer networks, pretty bad. And this whole recent phenomenon of bugs are no longer free, security researchers should get paid to disclose them, means a lot of people are sitting on 0 days, and there's a lot of nasty stuff out there. So, macroviruses. Who here remembers macroviruses? Well, they've mostly, like if you're not stupid, gone away recently. But 10 years later, so the Melissa virus was reported just over 10 years ago. It was actually in March of '99. Melissa is still in the wild. It is still out there. It is still propagating. This might seem pretty weird, but it is entirely true. So macroviruses are still a problem, but they're not limited to just Word. They're out there in other things as well because of auto-run. Anytime you have a program that says, run something automatically without the user getting to even vet it first, there's a problem. And Conficker, one of the big recent worms turning into a botnet lately, one of its infection vectors there was it spread through auto-runs on USB keys. So it would get onto your USB key, you'd plug it in, and then the next machine that you brought it to would also have Conficker. So what other programs use auto-run macros? Does anybody here use anything that has auto-run macros? Anybody? Okay, well nobody knows something, so I'll give you an example of it. AutoCAD. So AutoCAD uses Lisp for a lot of stuff, including its startup files and programming and auto-run files. So there are actually worms out there written in Lisp. And this might seem pretty ridiculous. Here is an example of parts of the code from this Lisp worm, but it exists. It is still out there. It is still propagating. And nobody has any idea what the hell is going on because they're like, why would I have a virus in Lisp in my AutoCAD? But it works and there it is. So one of the two really bad places for this sort of stuff, Microsoft Office malware. So I'm talking about anything in that suite, so Word, Excel, PowerPoint, any of that. How bad is bad? Well, has anybody here been keeping up to date on recent Patch Tuesdays? This last one, I think there were 7 or 8 vulnerabilities for Word. Every month, there are new Word and Excel ones, some PowerPoint ones here and there. There was an Excel 0-day floating around for quite some time that missed a Patch Tuesday and got rolled over to the next month and was 0-day in the wild for weeks at a time. Is it still 0-day? Maybe. There were a few of them. I'm not sure that they're all patched, so it might still be open. And even if it has had a patch come out for it, how many people here have updated their Excel in the last month? I'm guessing not everybody, which means that I could send you a spreadsheet, and that spreadsheet would then start logging all your keystrokes and sending them to a DNS redirector in China. It's pretty easy to do, actually, believe it or not, and it exists all over the place. So why are Word documents and Excel spreadsheets and all of that so complicated? The reason for this here is object linking and embedded OLE files. Each document in Microsoft Office, the older versions, is essentially a file system. So you have a set of streams, and the streams contain document information. Some of them are structured, some of them are semi-structured, some of them are not structured. If you want to embed a file in a document, you can just stick it in a stream. And if the stream isn't used for anything specific to Word, then it'll just hang out and never get used unless you write some shellcode to drop it. You can make a document that has the right streams with the right stream names, and if you open it in Word, it will be a Word document. If you open it in Excel, it will be an Excel spreadsheet. It is both of these at the same time, and if you open it in Word, there will be no indication whatsoever that it is a spreadsheet and vice versa. So there's all sorts of these crazy tricks that you can do, and a lot of times you can use this to hide data, whether it's embedded shellcode or some sort of executable dropper. You can also use it to data exfiltration. You can use it to hide information. There are all sorts of great tricks you can do with this, which makes it so wonderful for malware. So streams to look out for. For a Word document, you're going to have a Word document stream, and this has a data structure at the beginning, or the file information block, and that will give you all of the data that you need to know about various aspects of the Word document. So for example, if it is encrypted, there will be a bit set over there. If you are using extended Asian Unicode character set strings, there will be a bit set over there, and then these data structures over here will look a little different, and then these data structures over there will look a little different, and the whole thing's a mess. But that's how Word documents work. In an Excel spreadsheet, you'll have a workbook stream, and then you have these 0 or 1 table streams, which contain a lot of the information and content in the document itself. And the way this works is that the Word document stream, in that data structure, you will get pointers into another stream to the information that you're looking for. These pointers are just offsets into the stream, and there are many ways that if you do crazy things with your Word document that Word doesn't let you do, you can overwrite pointers and cause bad things to happen. So this is why there are so many vulnerabilities in Word and Excel and PowerPoint and all of that. It's sufficiently complicated, and they're using memory offsets. So you can make bad things happen. And what can we do about it? So exploits are easy to detect. Yes, yes, no. There are so many of them, and the spec for Office documents is so complicated that even Microsoft has problems with it. This might sound pretty funny, and it actually kind of is, but they have problems with being able to describe their own data structures, and there's recently been this huge initiative to try to make the specs more open to prevent all of the security issues that they've been having lately. They're making a lot of progress, but they've got many years of history of data structure after data structure and change after change that they're now having to process and figure out and try to document. The specs are hundreds of pages long each and are notoriously incomplete. So if you're looking for particular information on what this bit is in this stream in this document, you might be able to find it, you might not. Technically it's all there, but in practice it's a little harder. Fortunately, there are some people who are trying to collect ways of identifying these exploits for Office, and they're making it freely available. So you can take, like, for example, this tool OfficeCat, and it will run on a document, and it will tell you, is this document clean? Maybe, maybe not, or we detected the presence of this CVE vulnerability, so you probably don't want to open it. Other things that you can do is, instead of looking for the presence of the vulnerability, you can look for any malicious content in the file. You might think that if you have an executable embedded in a Word document, it's bad. This actually isn't the case. Apparently in Japan, it is common practice to distribute executables by embedding them in a Word document. I'm not entirely sure why they do this, but that's just how they do it. So you can have executable code in a Word document. The question is this an exe that's legitimate, or is it shell code, or is it a dropper payload? And this is the hard part of trying to find out what exactly is going on. But if you find executable code in there, then you probably want to look at it a little more carefully, unless you're in Japan. And the last thing you can do is use Office 12. The new version of Office uses a completely different format for Office documents. The format is, they're trying to standardize it with stuff that's already out there. So it's a gzip file with XML in it, and it does great things like separate macros from the rest of the file, so that if you want to set up some sort of gateway scanner to unzip files and delete any macros, you can easily do that. So it's a great way of actually preventing a lot of the malware in Office documents, and nobody uses it. Microsoft is pushing really hard to try to get people to upgrade for security reasons as well as for feature reasons, and nobody wants to buy new copies of Office, so nobody's using it. It's pretty bad. What can the malware authors do about this whole thing? Well, every Patch Tuesday there are more problems. Who's got the 0-day? And unfortunately, they do. There are many bugs out there which will go for months and months before somebody in an AV company notices it and gets back to Microsoft and says, hey, what's going on here? Usually the way these things work is that it will be around in the wild in very targeted cases. So thinking things like government espionage or specific targeted cases of going against NGOs or political organizations. And after a while, somebody will notice it, they'll file a bug, and then when the patch comes out, everybody will take a look at it, reverse engineer the patch, come up with the exploit, and then it will end up in those exploit packs. So you can spend, maybe $500 and just get this exploit pack that you put it up on a website, and whenever somebody navigates to your website, it throws everything at it and you're owned. So who's got the 0-day? The bad guys do, and unfortunately, people don't update their installations of Office or whatever else quick enough to actually stop this problem. And lastly, most people don't understand what it means when Word crashes and pops back up. In a lot of cases, if you have a piece of malware like this, when you run, say you open your Word document, what it will do is it'll trigger one of these vulnerabilities in Word. It will run custom shellcode. The custom shellcode will decrypt and drop an executable, run that. That executable will then open up the Word document, delete itself from it, and then respawn Word. So you will be left with an owned system and a clean document. And if you know what you're looking for, this sort of behavior, you can sort of catch it if you know that this sort of thing exists. But most people will see Word crash and then pop back up, and they'll be like, oh yeah, it's Microsoft. Like something happened, but it's working now, it's cool. And their virus scanner won't notice anything in the document, so everything's fine. And it really isn't. So I'm not going to get into a lot of the details of parsing file information blocks or anything like that. I do this a lot it's not that interesting, so it'll be even less interesting to you. But the specs are out there, and a lot of the older vulnerabilities are fairly well documented. So if you want to start digging through Office data structures, you can do that, and I'd be more than happy to talk to anybody about it later on. Next one, PDFs. I mean, how many people here use PDFs? Everybody? It's same as Flash. It's got a really high adoption rate. Everybody loves it, and it's pretty bad. Portable malware format. You might laugh at this now, but you might be scared in a few slides. So why is it so bad? It's got features. It's got lots of features. It started off as a way of being able to make neat documents and embed fonts and do graphics, and then JavaScript and database connections, and somebody wrote a port scanner in PDF, and it does all sorts of things that you really don't need in documents. And as those features increased, so did the vulnerabilities and the potential damage it could do. So it's got things like JavaScript, which are great, and it's got all the problems that you get in complex systems, so filters and encodings and all of that. Has anybody here ever looked at the PDF spec? Okay, one person. Trivia question. The prize is this fantastic mask here that didn't really work at concealing my identity. Anybody want to take a guess at how big the PDF spec is?
300 pages.
We have a 300. Do we have anything else? 1,000. Any other guesses? 1,700. Any other? Bigger than that. It's in PDF. Any other guesses?
301.
301. 2,000. Okay, so I think the closest guess there was 1,000. The PDF spec itself is around 1,300 pages, and that does not cover any of the add-in stuff, like, for example, the JavaScript documentation on what you're allowed to do in JavaScript in a PDF. So, congratulations. You get this wonderful mask. Go you. So there are really only 4 major vulnerabilities in PDFs. And that's kind of weird given how bad they are and how much doom they cause to the internet. And the really funny part is a few of these are brand new. So the old one is util.printf. There is a JavaScript printf function that their implementation has a buffer overflow in it. So if you use a format string, like that one down there, and you give it a really big number, it will cause a buffer overflow, and shellcode execution is not only possible, but it's easy. It's in every single exploit pack. It's on Millworm. You probably have a copy of a PDF that has this in it somewhere. It's out there, it's everywhere, it's bad, and all you need to do is encode some shellcode, which you can get from Metasploit or Millworm or any other number of places. Do a heap spray, which you can get from Metasploit or Millworm or any number of other places, and then call that printf function just like that. And then all of a sudden you have code execution, you're running your code on somebody's system, they're probably running as administrator, and everybody's doomed. There are 2 other JavaScript vulnerabilities. These ones are fairly newer. They're in the collab library. There's collect email info and get icon. They're both pretty much similar. All you have to do is create your buffer with your shellcode, do a heap spray to make sure it's out there in memory, then do your buffer overflow, and you have code execution on the system. Most malware PDFs like this that come in the exploit packs will actually use all of these, and they will look at the version of Acrobat that you're using to try to figure out which one will apply to you, and then it will hit you with all of them if it can't figure it out. These apply to Acrobat, so these are specifically for Acrobat Reader. And if you're thinking, oh, haha, I use Foxit, I'm safe, well, you're also wrong because Foxit has similar vulnerabilities. If you're using like the original GhostScript library, you're probably all right. If you're using like XPDF on some crazy architecture, you're probably all right. But these are not limited to just Acrobat, even though that's primarily what they're focusing So here's an example of some of that code that you might see in a malicious PDF. It does the version check, and then there are all these unescapes with the Unicode characters, and that's where you put in your buffer and your shellcode, and you create everything. And then down there at the bottom is the collect email info exploit. All you do is you put in that one line with a properly constructed buffer, and it's done. It's over. Another fun one, recent JBig2 filter. So PDFs can have embedded objects using a number of different encoding methods. And one of the image formats for encoding is JBig2. This is at the top how you would declare a JBig2 object in a PDF. So you put in this here, and it declared JBig2 and then points at a JBig2 global stream. And then you just say stream, and then you put in the data, and the data is your image. In most cases, this is totally fine, except the 5th byte in, if you set it to 40, skip a byte, and then put a larger number in after it, that will own your system. And that's all it takes right there. That'll crash Acrobat. There was a patch for this out on March 11th. Most people still haven't patched. And it's pretty cool because all it takes is that, and then from there you can, if you know what you're doing, write whatever shellcode you'd like. But it gets better. There are lots of features that PDF readers have, especially Acrobat. And one of them is this thing called integration with a preview pane. So if you click on a PDF, you get a nice little preview of it in your Explorer window or your Finder window. And the cool thing about that is that causes the vulnerable code in the PDF viewer to be run. So all you have to do is click on the file or bring it up in a window, say like under Linux, where it will try to give you a preview of the file as its icon. And the moment it does that, you're compromised. So you don't even have to open the file, you just have to download it somewhere where you're looking at it. And it gets even better is the Windows indexing service, which is often run on SharePoint and elsewhere, where it will go through all of your files and try to index them for you. So all you have to do is take one of these files and upload it to a SharePoint server, which has the indexing service active, and you have successfully compromised that server without any human interaction needed on the other side. Oops. And the best part is it's also cross-platform. So this will work on Windows, this will work on Linux, this will work on OS X, and yes, the iPhone runs OS X, so it might be a little more difficult to get code execution on an iPhone, but if somebody takes one of these PDFs and gets it in an email and opens it up on their iPhone, it will crash their iPhone and people will be very unhappy. And that's all it takes. It really is. Fortunately, there are a lot of tools out there to look at PDFs and get an idea of what's in them, as well as take a peek at the JavaScript and see what it's doing. There's one security researcher who's written an excellent PDF parser. It will just go through and list out all of the objects in the PDF file, and then if you see anything suspicious, you can take a look at it in more detail. If the object is compressed or encoded, it will handle that for you. The PDF toolkit does similar things. It's not as easy to use, I guess, because it's not written in Python. But it will, if you run it, it will dump the objects and let you see what's in the file. And there's this great program called Malzilla. It will take a piece of JavaScript and it will do things like decode it. It will run through all of the obfuscation methods that people often use in JavaScript. So one of these PDFs, usually you're not going to see the JavaScript in the clear. You're going to get a bunch of buffers with characters, and then it will call unescape and call eval, or it'll call document dot writeline to sort of unpack itself and take the encoded JavaScript and turn it into something that will actually compromise your system. If you load this up in Malzilla, it will do all this unpacking and tell you exactly what it is and what it's doing. And then all you have to do is look for one of those 3 functions that are vulnerable, and if those are present at all, then you know you have malware. JS Unpack, it's a website. We'll do the JavaScript unpacking for you as well. It's a really useful tool, or if you have something and you don't know what it does, You just upload it there and they'll tell you. So, what can they do with PDFs? The problem here is that detection engines are crap, all of them. And signatures don't work. When you're working with something that is essentially a text file that has 1,300 pages of spec written to tell you how this text file can be formed, you're not going to cover everything. And so signatures in this case by common antivirus engines will just not work. You can take a malicious PDF, and if they have a signature for it, you can do things to it that cause it to still be a valid PDF and cause the signature to break. So for example, any string in a PDF is enclosed in parentheses. You can use octal characters in that string instead. So if you wanted to put your JavaScript into octal, you can just do it that way. Or you could do a hex string. You can put it in angle brackets and just give the hex bytes, and you've got the exact same string, no problem. PDFs will also take Unicode. So if you want to encode your string into Unicode, all you have to do is put the byte order marker in like that, and then you have a Unicode string, and it looks completely different once again. Indirect references. So you can make an object that has the vulnerable, say, JBig2 object in it, or you can declare that and then just point it at another object. And you can chain this as many times as you want, and if you're trying to look for particular nasty content based on a signaturing engine, then you're not going to find it because you can have infinitely many different PDFs that all are functionally the same thing, so signatures just don't work. We've actually, there exist in the wild ones that will do polymorphic PDFs, where the PDFs will change, they'll rewrite themselves to look entirely different but still have the same content. So traditional virus scanners that work on signature engines will just never catch these. You can also take the PDF syntax and substitute letters for hex codes. This is a totally trivial thing, but when I was doing some experimenting with this sort of stuff and using VirusTotal, it's got like 32 virus scanners right now. Changing some of the PDF syntax keywords, adding a couple of hex bytes into them, dropped detection for every single antivirus engine out there that was looking for it. So this is a great way, if there's another race to zero at DEF CON next year, perhaps. This works great for getting malware around virus scanners. JBig2 global streams, again, it's another indirect reference where you can declare an object and have the object not be vulnerable, but then you can declare a global stream and put the vulnerable object in the global stream. So the global stream will never be directly referenced within the file, but it being there is enough to break everything. So again, all you have to do is even just click on the file. You don't even have to open it, and it's over. And same with deleting entries from cross-reference tables. The way PDFs work is they'll have a table at the end giving a list of all of the objects in the file. If you delete an object from the cross-reference table but leave it in the file, it will never be displayed. It will be ignored by any legitimate program, but it still hits the vulnerable code. So if you've got a parser that is going through the PDF trying to look for vulnerable objects, it will usually pull up the cross-ref table and then go through all of those objects, which means if you delete the object from the cross-reference table, it'll never be displayed, but it will still crash your program. Oops. So I guess this is a pretty quick talk, and I'll just open it up to questions. And I really didn't want to bore people with lots of hex dumps and stuff like that. So I'll just make some observations. And again, I do not speak for any company. I'm wearing this nice yellow shirt, just totally by coincidence. I speak only for myself and my independent research that I've done. Detection for this stuff is bad. And we're not talking kind of bad or somewhat bad, or sometimes it doesn't work, or oh, there was solar flares or sunspots and my virus scanner didn't work. But this is like, what the hell are you guys doing bad? And really the answer, or the reason for this, is that almost all virus scanner engines out there are looking for signatures. And this works really great when you're dealing with executables, because either you're looking for the malicious code in the executable, or you're looking for a packer or crypter signature that you associate with malicious files, or you have a depacking engine in your antivirus which lets you find the malicious code. So it's a little more straightforward there, but when you start looking at Office documents, which are sufficiently complicated that even Microsoft doesn't exactly know what's going on, then there's a problem. And when you start looking at documents that are text files with a 1,300-page spec, nobody knows what's going on there. And parsing them, the implementations are never complete. There are always interesting ways around this. So it's really in a sorry state right now in terms of detecting this sort of stuff. Some companies are better than other. I'm not going to tell you which because I could really get fired for that. But yeah, there are ways of detecting this sort of stuff. It's always improving, but this is an arms race where right now the good guys are kind of lagging behind. And not everybody is sitting on the sidelines with this. If I had to ask people, who do you think is worse security-wise, Microsoft or Adobe? Microsoft has this long history of being terrible with security and doing horrible things and killing kittens and all of that. But they're actually doing a really good job, especially with Office-based malware trying to fix these things. Bruce Dang from MSRC has given a number of talks on Office-based malware where he's upfront about everything and says, here's what's going on, here are the problems. And the reason for this is because MSRC is really trying to fix things and make things better. They're taking a very aggressive stance with fixing bugs, getting information out to people who can implement the patches and write the detection code. Whereas Adobe, when the JBig2 vulnerability came out, they said, all right, well, we understand this is a critical issue, and we'll have a patch for you a month from now. And then everybody freaked the fuck out and said, a month from now? That's not nearly enough time. Or that's too much time. We need this now. What can you do better? And Adobe said, yeah, actually, so a month from now, we're only going to release the patch for Acrobat Reader 9. If you want for lower versions, it's going to take longer, sorry. And if you're still using Reader 6, you're just kind of screwed because I don't think we're going to do that. So Microsoft is actually doing a really good job with this, Adobe not so much, and PDFs are everywhere. So it's pretty fun to play around with this and just try to see ways that you can compromise the system without using executable files. So these are the examples I had. If anybody wants to talk about other ones like images or HTML or anything that's not as crazy as this sort of stuff, we can do that because we have a little time left. So I guess, yeah, we'll just open it up to questions and see if anybody wants to know any more about this. So the question was, what is so bad about Flash? It is basically the same thing that is so bad about PDF, is that it's extremely high adoption rate, and vulnerabilities for it can be cross-platform. So there was a Flash vulnerability that came out a while ago that it happened to just work just as well on Windows as it did on Linux. And I mean, who here doesn't use Flash? Anybody? Everybody here uses Flash? All right, there you go. It's a matter of just adoption rate and the cross-platform thing. And the fact that I've heard now you can even take C programs and compile them and stick them into your Flash, and then you can do something like, or what those researchers did where they wrote a port scanner in Flash that would scan internal IP addresses, and then they paid $50 to put this Flash banner ad into rotation, and it ended up off on all sorts of major legitimate sites, and they got thousands and thousands of port scans of internal networks behind people's firewalls. Oops. Oh, wait, we have...
Which one do you want to take first?
You've got the microphone, so...
Sweet. Any comment on Silverlight and Google Native Client?
I know absolutely nothing about either of those. Silverlight, I just try to pretend doesn't exist and hope it's going to go away.
If you want a good laugh, you should look at Google Native Client.
All right.
What do you think about the effectiveness of sandboxing programs like Sandboxy, for example? Do those really protect us from malware when they are opened within such environments?
So sandboxes are an effective method for doing, it's an additional level of security which works in many cases, but like any other security technology, it will not work in all cases. It's definitely something that's very valuable to have, but you shouldn't feel safe just because you have it. There's always a way out of any container environment. It might be a little harder. It might take a little longer before somebody figures it out, but it's an arms race. It's a very good tool and should be used as part of this arms race, but it won't make you safe.
So the thing with Microsoft indexing service, does that run privileged? So if an unprivileged user uploads content to a SharePoint server, will indexing service run as
Yes.
system on that box?
Oh, I don't know what it runs as, but even if it's not...
It's local system.
Local system? Okay. Even if it's a non-privileged user, there's still privilege escalation stuff all over the place in Windows, like that recent one from this month. Any other questions? Another one over here.
Anything in particular you'd recommend for porn browsing at this point? Like no script?
No. It's funny to laugh at, but the problem here is that a lot of these sites, a lot of the times, they don't even do it intentionally. There are a lot of things that look for SQL injection vulnerabilities or cross-site scripting stuff, and they use that to throw these malicious iframes into a site. And porn sites are great because they're sufficiently sketchy that nobody really cares or notices or whatever. So you really have to be careful with where you're browsing. Some places are worse than others, like that one experiment where these researchers basically made a site that did drive-by downloads and put an ad up on Google Ads that effectively said, "Is your computer infected? No? Click here." And it worked. It's really bad. The AV industry is doomed. Go back to that first picture. The AV industry is doomed. But there's really nothing you can do in that sort of situation. All you can really do is make sure your browser is patched as much as you can. Some of the technologies in Chrome look pretty decent, but it still hasn't been enough time to prove itself whether they are actually effective containing mechanisms or the problem is Chrome is still sufficiently new that it's got all of its own vulnerabilities in it. So as that technology becomes more stable, it'll probably be better than other browsers, but it's still not there.
What about like behavioral-based antivirus, like heuristics? Does that have, is anything really out there that can detect those?
The alternative to signature-based engines are heuristic engines. They work better in some cases, worse in other cases, but in situations like this, where you're looking for something that you can't possibly have signatures for, heuristic engines are the way it'll work. Behavioral engines will also work, but they'll also probably notice it after you've been owned already, as opposed to before, which is where you want to try to catch things, usually.
Sort of elaborating on his question, could you comment on the IDS systems that are at the API level, as opposed to like running an antivirus software? If you have like an IDS system that filters out low level or certain APIs like write process memory, are those systems effective?
They are if their heuristic rule sets are good. That is effectively a heuristic-based antivirus as opposed to a signature-based one where You have rules that say if you see this weird thing going on, then it's malicious and block it. If your heuristics are good, then that will work. The downsides to heuristic engines are that they're slow. The heuristics might be wrong. There are more false positives. So there are advantages and disadvantages of both sides, but you should ideally be using both. And that is a very important component of that kind of a system. All right, well, thank you very much, and have a good day.